Where do you want to create an impact in your life? Anja?
Where? Maybe my professional career, maybe?
Maybe.
Yes, in my academic career.
Where do you want to create an impact in your life? You might have fantastic children, that's an impact. You might win the Nobel Prize for your research. You might come up with the next big trend in social networks. That's all an impact. Anyone? Where do you want to create an impact in your life?
Help people, save lives, maybe.
Healthy people, save lives?
Yeah.
That's my impact. That's not fair.
Increase the lifespan of the society.
Okay. Is it a good thing?
Yeah, it is. It can be bad and it can be good.
You think so? It can be good and it can be bad?
Yeah, of course.
That's true. I would like to do a similar thing, but I would like to increase the healthy lifetime of the society. And of course, I thought long and hard about this, so my answer to that question is rather easy. And what I would like to do tonight is to lead you through my point where I would like to do an impact in my research life. And that's gonna lead to a longer, healthy lifetime of the society through the means of ubiquitous health methods. And what that is, I will present you in the slides, in the talk, in a more general and broad scope, and also in a couple of really dedicated research projects that we conducted. But let me first start to introduce myself a little bit more in detail, because many of you might not know Friedrich Alexander University Erlangen-Nürnberg, where I'm from, and where actually Cristiano and Sandro Rigo, another professor of this university, visited for a longer period of time, half a year each of them, to get to know this system and get to know this university and this ecosystem a little bit better. So I'm coming from here, that's Europe. Who can find Germany on this map? So Germany is, of course, this region here, and my university, Friedrich Alexander University, that's the logo, is proud to be in the center of Europe. That's, of course, a marketing slide, so I'd like to show that. Just so that you can place it on a map, more or less good. So just a little bit of information about my university. We were recently ranked the most innovative university in Germany, and actually 5th place in Europe. So this is the ranking, the Reuters ranking, KU Leuven, Imperial College London, University of Cambridge, Federal Institute of Technology in Lausanne. That's universities that you have probably heard of. You might not have heard of FAU, as we like to abbreviate it, ever. Welcome to the club. So we have a famous ambassador who's from University of Cambridge, and he said, this university, FAU, is the best university you have never heard of. You know, now you heard of it. We were founded in 1743, so a little bit older than this university, although not by far any of the oldest universities on this planet. We have 5 schools compared to your 6. 40,000 students. This makes us one of the top 10 in numbers of students in Germany as well. 580 professors, so the ratio of professor to student is a little bit worse, or way worse than here. So again, congratulations, you're studying at a place where lectures and education is still in a good ratio. And we have 180 million euros of third-party funding. That makes us actually the 3rd place in Germany. So just that you have a little bit of an impression of the university that I'm coming from. I have a slide about our research foci because they also align well to what you do here. At least that's the impression I got this morning when I talked to Father Marcelo, your rector. So especially electronics, analytics, and digital transformation, medical engineering, medicine and life science, health, and optics and optical technologies. That's areas of our research foci, which I think align very well with your university, the place that you work and study and do research in. So we are working, and that's the purpose a little bit of my visit, on exchange programs. So the best of you, the most motivated, the most dedicated, feel free to reach out to Cristiano, to Sandro, to check out whether there's a possibility to come to this university and to do a little bit of research time there as well. The area that I'm specifically representing is health. And let me show you why FAU and its environment is so well suited for doing healthcare research. So within Germany, and here again the map, if you forgot, and here that's Germany, and to place it a little bit better, the region that I'm talking about is this yellow region on the Germany map. So that's the north part of Bavaria, still in the south of Germany. So we still drink a lot of beer and eat a lot of Weißwurst. And we sometimes wear lederhosen, yes, that's true. If you want to see that, visit us around June, because then our famous Bergfest happens. And I think Vinicius is already looking forward to
Hopefully.
that. But all fun aside, we are also a reproductive region, and especially in healthcare. So the fact that we are the most innovative university in Germany stems partially from the fact that we have a lot of industry collaborations in the healthcare space. And in 2006, the German government made us the healthcare region of Germany. So they had a cluster of excellence competition going on, and several regions applied for specific strengths. We applied for medical engineering, other regions applied for it as well, and we got it. So since then, we are branded the Medical Valley of Germany. Well, actually, this cool name we came up with ourselves. But it comes from this cluster of excellence competition. And that was worth 40 million euro that the German government gave to our university and to its partners to build a strong healthcare technology ecosystem. So why is that? Because we have a strong partnership in the area already. Back then in 2006, so Siemens Healthineers, the global company, is originating from this very region. They have the headquarters there. Adidas, I heard this morning that some people don't know that Adidas is coming from a small town in Germany, actually also Puma, but let's not mention them anymore tonight, because they are the competitor, the local competitor, of course, of Adidas. And little piece of trivia, if you don't take anything away from tonight and you didn't know it, the founders of Adidas and Puma were brothers. And they're coming from the small town of Herzogenaurach, and that's on this map right here. So a strong global company that's coming from our region, and a company that arguably contributes to the health of our society. We also have a number of startup SMEs, small medium enterprises, hospitals in this region that see a lot of patients every year, so a strong healthcare region. And this places us in the center of interest in the German healthcare ecosystem, and therefore I'm proud to say that I'm coming from one of the most innovative regions in Europe in healthcare research. That's where I'm coming from, and I'm of course also, besides doing advertisements about my university and representing actually the research focus of my university, that's medical engineering. I'm of course also sometimes doing research, and the research that I do, I like to do in the Mad Lab. So you might think, what is that? It's the abbreviation for the Machine Learning and Data Analytics Lab, and we're proud to say that we are the crazy side of artificial intelligence, and that's why Mad Lab fits so well. And I think Cristiano can attest to that, right? So what do we do there? Our focus is to increase human well-being. So in all phases of life. This might be through cooperations with Adidas, where we try to target human performance in early phases of life. It might also be monitoring of illnesses, and I have a few research examples on that a little bit later. So across the whole lifespan, we try to contribute to something that I call a digital healthcare ecosystem. And I show you what that is a little bit later. So in terms of research pillars, in terms of the hard computer science that we do, we work on machine learning and data analytics algorithms, and on variability of these systems that we derive our data from, and their usability. Because it is my strong belief that you, as contributors to anything, you always have to keep your user in the center of attention. So who's your user? Always think about that. Who's your user? Vinicius, what are you currently doing? What's your most important project?
My most important project for me is the patient in the operating room.
It's not a project.
For me,
A patient is not a project. Come on. A patient is a human being.
yes,
that has-
the health of the patient, to keep the health of the patient.
Okay. How do you do that?
By monitoring a lot of sensors that are monitoring the patient.
So who's your customer?
The patients, the society.
Oh, that's completely different stakeholder groups. The society and the patient. Here we have one individual that suffers from an illness, and a big society that has all these things going on. You know, healthcare providers, insurance companies, they have completely different wishes from your patient. They want to keep costs down. And who else belongs to society? Researchers belong to society. They maybe don't care that much about the patient. Who else is in that ecosystem? Doctors, medical experts. Wow, they are crazy people. But I think if you want to change anything in health, they are your first customers. Because if you don't convince those people, the medical experts, to use whatever you're doing if you want to contribute to health care, you're not going to change anything. Except you may convince a patient to use a system that you come up with. That's a different story, but R to B is easier than R to C. Research to business or research to consumer. So I can attest to that because I founded 3 startups in the healthcare area, and it's quite hard to address this kind of end consumer. So always have your user in mind. That's why usability, I think, is so important. And in our work, at least, we try to have this spin by constantly making the master students, the bachelor students, so we also write thesis projects and bachelor projects. The PhD students, first and foremost, they have to spend a day a week with their research partner. And that could be the industry, it could be a medtech company, it could be Adidas, it could also be a clinician. And if they work with a clinician, they better spend a day a week with them, actually collecting patient data themselves. Because it's a huge difference whether you use data from the internet that somebody else collected, or you go there and you actually see a patient walking with your system, or having all the kind of problems that a real system will present to the patient. I give you a little bit of a story. One of the startups that I work with, and you'll see it later, works with a gait analysis system. And there's this test that you will see a couple of times later. It's the 10-meter walk test. So this is done in neurologic hospitals all over the world. They all do these 10-meter walk tests. And it's a clinical standard. And it's important in this test to see all phases. The acceleration phase, the phase when you have constant walking speed, so 4 or 5 steps in 10 meters, where you walk more or less constantly with constant speed, and then the deceleration phase. So we had an end customer. We gave the system to a user, and he was told, more or less straightforward, that he should do these 10-meter tests. You know what happened?
He didn't do?
He did do a lot of tests. We were quite happy when we initially looked at the data. What else could go wrong? That's a hard question, I tell you. So the guy thought, oh, I can walk more than 10 meters. I just do 20 every time. That's of course a good idea, but that makes the whole data not comparable anymore to our big data set that we have. So we can more or less trash it. What's the story? What's the thing I want to explain? You always have to think, what could go wrong? What could the user do? What could happen with my system? And we constantly try to ask these questions together with clinical experts, together with patients. And it's hard and it's tedious and it's painful, but it's important. So please, if you ever contribute anything in real life, go talk to your customer. And this might be, as we just learned, different stakeholder groups. The patient, the healthcare insurance company, the clinical expert, the the researcher, whoever. Identify those stakeholders and work with them. Okay, I spent way too much time on this slide, but this is important. If you don't take anything away from this lecture, presentation, take this away. Okay, so we have applications in the sports technology field, in the healthcare technology field, in the medical field. And just as an example about the sports field, so this is my current lab, where Cristiano and Sandro spent a little bit of time. Well, actually, Cristiano was still in the old lab. This is the new lab, so quite nice, in a location in Erlangen. And this is Herzogenaurach, so really close distance. And this is the world headquarters of Adidas, where I like to spend a day a week. My busy schedule doesn't allow me to, but they have way better food and way better office space. So I like to be there. And they have one of the best biomechanical laboratories in the world. So this laboratory that they have is worth some 20 million euros. And we as a university get to use it. So some people in Germany doubt whether industry-academia relationships can be fruitful. Yes, they can. Because we as a university, we would have a hard time getting a 20 million euro biomechanical laboratory in place. But they have it, and it's unused 90% of the time. And they're happy when one of my researchers come and collects data there. So this is a fantastic and fruitful collaboration. My team is organized in different domains of application. And here are a few examples of that. So the lab, the Mad Lab has currently 30 people working for it, 25 PhD students, 3 postdocs, myself, I also sometimes work, a team assistant. And we have strong collaborations with industry, not only with Adidas and Siemens Healthineers, but also with Philips, Bosch, a few others, also small, medium enterprises that are not that well known. And we work really closely with the domain experts in our field. So with health psychology, with medicine, with sports science. Because I, as an engineer, I know that I can do really good engineering, but I'm not a good medical expert. I have a second affiliation with the School of Medicine, so I can actually give medical doctorates, but I have no clue. I'm not a medical expert. And therefore, whenever a medical question arises, I send my PhD students to the experts. I let them ask those people that actually know. And because I think that's so important, I always like to bring a medical expert to my talks. So please meet Jochen Klucken, he's a neurologist, and he will answer a few of the questions that I have later in my talk. So currently he just says hi, but this is a real expert. He knows about neurology. He knows about Parkinson's patients. Okay, so what is ubiquitous health? I promised this grand title, and now I have to deliver some content on this. So ubiquitous healthcare is a patient-centered healthcare system where we can provide quality of life to real people in all phases of their life. And for that, and talking about stakeholder groups and the society, here you have it. So the society is all that stuff here. So you are talking to insurance people, you're talking to politicians, the state, and believe me, they can create a lot of friction. When you talk to the health minister of Bavaria and you tell her, we have found the research solution to all of our problems, she's like, yeah, but not in this legislature because it might create problems with my voters. So thank you. You talk to medtech company, biotech, you talk to pharma companies and many more stakeholders. You have all kinds of data creation tools to your availability, digital DNA, wearables, 3D printed devices, AI, whatever. But all these are just a means to an end. And that's giving this person, this patient, information about all these things that he's interested in. My patient data, where is it? Is it in the cloud? Or is it in a package that I get sent from my medical expert? That's at least how it works in Germany. So we are currently getting our 4th child. And because my wife was not protecting the piece of paper where all the information about our new baby was stored, as well as with the other kids, what happened now is that she poured a cup of coffee over the paper. And now all the data is lost. It's gone. It's not available anymore. So I mean, it's gonna be not probably important how much the kid weighed in the 12-week pregnancy, but still it's data that's lost. So that's bad because if we really want to live up to the promise of AI, of telling something about real people, we need a lot of data. We need good data. So if all this is lost, this paper stuff, it's not going to help. So we need digital representations of data that make this promise of the AI world really come to life. And then at the end of the day, the patient is just interested in maybe this. How am I actually doing? Also compared to yesterday and last year, and maybe how am I going to do tomorrow if I keep on smoking or whatever I'm doing. So who's this person in the middle? I always like to ask this question. Who is that? That's me or you. That's an individual person, and our current healthcare system does not really work well for this promise. Because we are currently working a lot, first of all, in research on you guys, mostly. So on young college kids. 80% of our research results are based on 20 to 25-year-old study populations. That's because they collect data with you. And they're not really well representative of the general population. And by all means, they work on exactly that, on mean values. But that's not an individual patient. We need data from individuals. We need to solve all the data protection privacy issues that are out there and that are valuable, that are important. But we need access to data from individual people. And therefore, I'm pretty proud that I'm part of a project that tackles this very problem or this very challenge, because together with Siemens and with Adidas, we're currently creating a digital twin of a human. And that's really a large promise. So it's a digital representation of yourself from the moment you are coming to life. And I don't mean your birth, I mean the moment you are incepted. There's already a lot of data created in that phase. We have ultrasounds, we have blood samples, we have all kinds of things that are investigated. And this is your very first healthcare profile, and currently more or less inaccessible. We're creating digital representations of your organs. Of course, that's a huge business field for Siemens because they do medical images and they can follow your organs across time, and they can relate your old ultrasound image to your new tumor image. So this is interesting applications and also an interesting market for them. And we are creating the digital DNA of an athlete together with Adidas to better understand the individual needs of a person and also how the needs are changing across time to give you a better product recommendation. So you shouldn't wear Nike shoes anymore. I saw that. Get Adidas shoes.
Yeah, I don't have one. I thought about it. Oh, that's so American.
I'm just kidding.
I have a Puma now.
So this is the world that we are going towards. You will be born at some point in time in 20 years with a digital representation of yourself. I don't know how it's connected to you. It might be a chip that's implanted. I don't know. It might be just a cloud space with your personal data. I'm not talking about healthcare data only. I'm also talking about your address. So do you know how tedious it is in Germany to change your address? You have to write to 100 different companies, and some of them just lose your letter and still post your important tax data to some old address. How cool would it be to just change the address in your personal data space, and then everybody knows? And everybody, when they want to send you a letter, they access this data space and they send you the letter to the right address. That's the future we're going towards. And this is going to be fantastic for healthcare. We just have to fill it right. And there's a new world coming up that's really fantastic. And that's this world of the Internet of Health things. And one of the most productive things that came out of Cristiano's visit was a fantastic publication that we had in the Artificial Intelligence in Medicine journal about this very thing. So the Internet of Health things. And that's everything that is connected to you, to your health data, that's generating information about how you're doing. And it's not only the obvious stuff, like your wearable or your latest medical record. So in the US, during my time at MIT, I set up a project together with Kaiser Permanente, that's a healthcare insurance provider, Toyota and MasterCard. For healthcare. Why? Why could this be interesting? What do you get from Toyota? Okay, think further in the digital world.
Think about roads.
Think about roads, yeah. Maybe interesting, I didn't think about that. You get mobility profiles of people. Especially interesting in the US. Is the guy always driving to the bakery that's just a mile away? Or is he sometimes Sunday mornings not walking when the weather is good? And not driving when the weather is good. And he's probably walking or riding his bike. And what do you get from MasterCard? Yeah. You know whether the guy is shopping at Walmart, the discounter, or at Whole Foods, the premium goods seller retailer. You know whether he actually owns a bike that he could use to drive to the bakery. And all these things, so all these information pieces are going to meld together in the future to give us information about who we are as humans. And it's actually already happening. So who of you uses Amazon? I do. So what happens when you type in, I want to have a red, whatever, I want to have a red bicycle. What happens in milliseconds? You're being assessed as a person. Your personal profile is going to be matched against this personal profile of thousands of other people. Thousands of other people will generate one person that's really close to you, or several persons, and then several persons are searched for this person that also wanted a red bicycle. And then it's going to check against what bicycles did this person get recommended and which one did it actually choose. And that's the same bicycle that you are going to be presented if you have the right financial possibilities to buy this real bicycle. So that's the world we're actually already living in. But why don't we do that for healthcare? Right? If we had access to all the data, we could do the very same thing. Amazon can just do this because they have all the data. In healthcare, we can do the very same thing if we know, okay, I have a problem with my knee. There is thousands of other people that have the same body height, that have the same amount of sports, that have the same injury history. So what's their prediction? How are they living 10 years after the injury? What kind of surgery did they get? What kind of physiological treatment? Rehabilitation and so on. And this is in the future going to be matched against our personal profile and we get the best recommendation for our personal health. That's the world that I want to contribute to. Okay, that's a big promise. I have a lot of time. I know that I'm going to work 32 more years, so at least in the German system currently. So I have a lot of time to let this vision come to life. But let me show you what we contributed to this world so far. So maybe interesting for you what my research career started with. It was a PhD project together with Adidas, and it was already about health. I didn't know at that time to put it in that perspective, but this is the first thing I ever worked on. This is a shoe that came on the market in 2008, and we published the study about it in 2009. So the shoe was including a wearable system, an embedded system that continually measured the compression of the heel part of the shoe, delivered this information to a microcontroller that was embedded in the shoe, and the microcontroller made a decision about what's the status of the runner. So is he running on hard surface or soft surface? Is he physically fit or is he already fatigued? And this information was then processed by the microcontroller, and the microcontroller could make a decision about this cable system that you see here in the X-ray. And the cable system can be tightened and shortened, and tightened and loosened. And when you loosen it, then you see that you can create more room for this oval element to allow damping. So it compresses more. So you can control the shoe between 2 millimeters and 80 millimeters of damping. Why?
For better performance.
Performance is not allowed. We asked the International Olympic Committee whether this shoe was allowed in competition, and they said no. This is technology doping. That's true. And I cannot agree to that because the shoe was actually 80 grams heavier per piece than the normal competition shoe. That didn't make sense to wear it at all.
To reduce the stress of running to the body of the athlete.
Exactly. So you are starting, this is the real example that I gave, you're starting to run here on hard surface, on asphalt. And if you have a lot of cycles on asphalt, after 10,000 steps, you will have a higher chance of injury to your knees and to your hips and to your back if you don't create more damping. But then what if you change to grass surface or to the woods? There you have a softer surface, so you don't need a lot of damping, but you want control because you don't want to step in a hole, lose control, and tear some ligaments. That's the trade-off that you have to do in normal running shoes. And this trade-off is solved by a technological system. And I did the machine learning part for that. I did the recognition, what's the state of the runner. So I'm really proud to say that I'm the computer scientist from Erlangen that got his software implemented on the most individual products. So this shoe was sold 1.2 million times. So quite an achievement. I didn't get 1 cent royalty, by the way, from any of them. But it was a cool project for my PhD nevertheless. So after this experience, I built a research group in Erlangen, and this research group revolves around those challenges that I just gave you. So this is an image from an early research project from 2010, but I think it's still valid. What we do is we put sensors on bodies of athletes or patients. We foster the synchronization and communication of these sensor nodes. We integrate sensors in equipment, just like in the case of the Adidas One, the shoe that I just showed you. So together with those companies, we can really integrate sensors in products, and that's pretty cool. We work on the embedded recognition of information, so we work a lot with wearables to make AI, machine learning, running on these kind of devices. As I already told you, I keep an eye on the feedback, so I make the data accessible to individuals. So I work on the human-machine interface aspect. We put all our data on the web because we're already trying to feed data towards this digital twin. So all our data is machine learning, readable, and also reusable for later research studies. So if we come up with the better algorithm, we can just apply it to the old data that we have collected. And a lot of our data is, by the way, available on the internet for research purposes. And with that data in the cloud, we can, of course, close a second feedback loop to athletes, other athletes in the social network, to medical experts, to coaches, to whatever. So this is really a very nice environment to work in. So some results that we had in these research studies over the years. So a lot of work on sensing systems. So as I said, integration. So we have built our own wearable ECG system, a soccer system that won a Best Paper Award at a conference because we were the first ones to actually measure the contact of the ball with the shoe and to predict where the ball is flying. So for those soccer fans of in the area, we can predict the spin and the speed you create with the ball, and we can give you training advice to actually do it better. By the way, never made it to a product, but the patent is still sleeping somewhere in the Adidas portfolio. We worked a lot on medical questions, a lot of sports questions. So ski jumping is an example. If any one of you watches the Winter Olympics and has ever seen a visualization of the jumper in the air, like the angle that he has with his skis and how much they are vibrating, that's a product from my lab as well. So one of my PhD students did the whole system, the telemetric system to collect data from the skis, to put that into a biomechanical model to drive the visualization. And the visualization was then done by a company that's working for the Olympic Games to do the visualization. So that we don't do products all the time. Mostly we, of course, focus on the research. And something that I want to focus on for the first few few slides is something that is dear to me, and that's biomedical signal analysis. So what could you do with that? I know that Brazil is fond of soccer. Let me show you what can happen in soccer. This is the famous case of a Hungarian player, Niklas Feher, and he actually died on the soccer pitch in the age of 24. Why? Because he had a sudden cardiac arrest, and it was really unfortunate that he couldn't be revived after this thing happened to his heart. Why am I telling this? Because it's really a shame. The symptoms that are leading to the sudden cardiac arrest are easily visible in the ECG. You just have to see it, you have to detect it. And you can bet that this guy was wearing a lot of his times some kind of training device, like a polar heart rate monitor that is just there for training monitoring purposes. So it gives you your heart rate. But these devices can do way more if you apply the right technology and the right AI to it. So we are building since 2010 a framework that we call Hearty that allows real-time ECG analysis on a mobile device. You can download the framework, we share it with the community. You can build on it. We build its recognition on available database, the PhysioNet database. And what it does is really simple. You stream data into the mobile platform, and it gets analyzed for several important clinical parameters that were developed together with clinical experts. And it does, if you want, a simple classification of the ECG into here's a heartbeat, and here's a good heartbeat, here's something that's going wrong. And if we have too many of these, here's something going wrong, then it's a good warning sign to send you to a cardiologist. So for many of the research studies, we use our own developed system. Of course, that's not wearable, that's not integratable into daily life. So what's the reason that this stuff doesn't exist on the market yet? Mainly signal quality. So with the heart rate monitors that you can currently buy on the market, you don't get the signal quality that you need for this kind of ECG analysis. However, you can, of course, have better signal quality if you use something like this, if you use connected electrodes. That's not really feasible for everyday use, right? So Niklas Schleher wouldn't have used such a system, probably. So we have to solve this, and luckily we have one of the largest Fraunhofer institutes. So this is a research institute, just like your, what's it called, ITT? So it's a research institute close to universities, but not university itself. It's there for technology transfer into real applications. And therefore, we had a project together with our Fraunhofer to build a wearable device. So this shirt, they call it the fitness shirt, that has improved signal quality. So we worked a lot on the measurement technology to make this dream, this vision come true of clinically usable ECG data that can be streamed into a mobile platform. So this is currently marketed. It's not taking off that well, but at least it's out there on the market. And another positive aspect, this guy who was working for Fraunhofer as a model is now part of my lab. Girls, that's good. If you want to come visit, it's a good incentive, I guess. Okay, so where else could you apply this heart rate monitoring stuff? Okay, the case with the sudden cardiac arrest is pretty obvious. This is not so obvious, and I like to tell the story. So we teamed up with a startup that was pretty successful in Silicon Valley, which is actually a spin-off of IMEC. So IMEC is like Fraunhofer, but from the Netherlands. Forget it. They are a pretty successful startup called Bloom Technologies. And what they developed is a wearable system for pregnant women. And they were recently funded by Richard Branson, the founder of Virgin Airlines, with $35 million. So pretty successful, I would say. Before they were that successful, so 3 years ago, I guess, we worked on a project together with them to make their system, which is more or less like a Fitbit for pregnant women. So it tells you how much activity you have. It gives you recommendations on what to eat, your nutrition. It monitors your sleep. But we thought, I know Julian, the founder, for a real long time, because he's in the same community as I told him, why doesn't it measure baby health? It measures pregnant women health, but not baby health. Why is this relevant? I'll give you an example. So when we were pregnant with our, I didn't want to do that. When we were pregnant with our first kid, my wife and I went to the Austrian Alps, 3,500 meters, and she insisted to walk up there herself in the 6th month of pregnancy. She's my wife. I can't convince her to do anything else that she wants. Yeah, that's fine. But then the baby that was happily kicking before, or every day, or a couple of hours every day, she didn't feel it anymore. In a more or less remote region in the Austrian Alps. So in Germany or Austria, this is still okay because you can just call into a hospital and a helicopter will come. But still, it's a quite high hurdle to call medical expert in that situation. Luckily for us, it was okay because in our with us were some medical expert friends who told her, yeah, the baby's fine, he's just sleeping because you're exhausted, he's exhausted, everything is okay, will be okay. They didn't know for sure, but they were just making an assessment of the situation, and happily the next morning Maximilian was kicking strong again, so everything fine. But imagine you're in rural Kansas, or you're in the middle of Amazonas region, or you're somewhere in India where the next medical expert that could tell you something about the situation is hours away. Then you really feel like shit. And in this situation, stuff like this, these wearables can help because we teamed up in order to bring our ECG analysis system into their product. And it's not released, it's not FDA cleared yet, but they're still working on it to actually tell you something about the heart rate of the baby in the later phase of pregnancy. So you cannot only monitor your own health, you can also see, okay, Maximilian's heart is beating happily, 170 beats per minute, everything's fine. So that's cool. Something else that the system is doing, by the way, giving you workable data, actionable data. So for those of you that have not been pregnant, also for the men that have never had a pregnancy live in their family before, so they tell you that you should go to the hospital when the contractions come every 10 minutes. You know what happens when your wife has contractions and you ask her, hey, how often do they come? Leave me alone! So it's really like that. I experienced that situation. There's no objective data anymore, right? So this system, of course, gives you objective data on the contractions, and then when it's really every 10 minutes, it's better time to go to the hospital. So we can deliver real interesting information about the health status of real humans with these kinds of systems. Okay, something else that we did, and I just pitched in these two slides, mental state recognition. This was another collaboration project that I did over my time at MIT, was to use wearable devices like this virtual reality system together with Muse. That's a system that gives you information about EEG, but we are now including the EEG system in the virtual reality headset because it's the same location more or less. And then you can use these kind of data, these kind of biosignals to tell something about mental state, about relaxation. There's a few good, well-accepted parameters in the literature that you can derive from EEG data that tell you something about how relaxed are you. Stress, because everybody wants to measure stress, I'm not so sure about, but at least relaxation you can target quite well. I hope that this is more or less true, Andrea. I'm not sure. I always try to talk to the experts, So the focus of this study was to measure relaxation. We built a room where students, in this case it was students, can relax, and we measured their academic performance with or without use of this relaxing room. And I can tell you that the academic performance, at least of the MIT students that went through this experiment in the relaxing room, was better. So it's a good idea to relax the evening before an important exam. That's another important outcome of the study, although it was not the research question. We also took this away and took this around and measured the real-time stress situation. We didn't call it stress, we called it focus. So how focused are you? How much inner flow are you when you're working on a problem? And try to control the room. So this was the environment, this was the relaxing room based on this information. So when you were trying to relax, we were giving you a feed of information that was, trying to kind of arouse you. And the other way around, so when you were really focused, we also did the same thing with relaxing and stimulating environments. And just checked how this affects your ability to focus or to relax. And The learning here is that if you're really focused, it doesn't matter what you do, but if you're relaxed, you can easily get out of that state by the wrong stimulus. So if you want to relax, better search a really calm atmosphere. If you want to focus, it doesn't matter. If you really want to focus, you can. Important learning. Okay, so I see a few people looking at the watch, so I guess it's time for me to slowly conclude the talk. Just and I'm really wow. So this is it's 8:30 and most people are still looking. So smartphones out there, that's fine, of course. But another important learning from our studies: if you look at the smartphone and you think you can listen to the lecture, that's not true. So you are losing 80% of memory capacity when you look at the smartphone. So when it's just open, when the screen is just unlocked. So if you, I mean, you don't have to follow me because I'm not going to test you, but if you follow one of your professors, it's not a good idea to have the smartphone out. Or even if you think you can, humans cannot do dual tasks. Ladies, you cannot as well. That's proven. Okay, so last but not least, I want to give you some information. I'm going to go through that a little bit faster and not give you a lot of stories about measuring neurological conditions as part of this healthcare ecosystem that I was talking about earlier. So what are neurologic conditions like Parkinson's disease? This is a good depiction of how Parkinson's disease feels to a patient. This is a real Parkinson patient, that's Sarah Rigare from Sweden, who used this image in her blog post. So Parkinson's disease is always present. It's a disease that's existing in all phases of your life. And the blue dots here are the hours that Sarah spends with her disease without getting any information about the disease that's tangible. And only this little red dot here in this top corner is the 1 hour, half a year, each half year she spends with her treating neurologist that gives her actually good, actionable information of how am I actually doing. So that's the individual patient view. If you put that in perspective in the healthcare system, you can depict that a little bit different. So we have a plot here with symptom severity, so how are my symptoms, and disease progression, and acute illness. Most of us know, so this is developing a cold like I have currently, and this cold makes you have symptoms. You go to, well, maybe not with a cold, but maybe with some other illness. You go to see a doctor, you get diagnosis and therapy, and hopefully you're doing the same after. Sometimes there is symptoms remaining. So if you have, for example, a knee surgery due to ACL, anterior cruciate ligament injury, you will get in a stable state again, but it's not going to be as good as before. I know that because I had an ACL injury. But it's at least stable. So that's the world of acute injuries. With chronic diseases, the world is completely different. And my uncle suffers from Parkinson's disease. So I see him very often and I know how he's doing. So sometimes, some days he's really doing good. And then other days, especially when all the relatives visit, he has a really bad face. So he's breaking down. He cannot stand talking to people anymore. And you see him trembling and you see him almost falling. And this is a disease that's really affecting the person every day. And the problem is that the person himself often doesn't know in what phase he's currently. Is the disease progressing, or is it actually getting a little bit better through medication? So ideally, we would need diagnostics and therapy connected to all the phases of this development. But this is totally not the case. As I told you before, with Sarah Rigare, patient sees doctor, at least in Germany, every half year. So not a very good situation, because the doctor might be here, and oh well, nothing progressed. That's what the doctor sees. But in reality, there was this huge fluctuation in symptom severity. And maybe it would have been a good idea to give new medication here, but it didn't happen. So we need systems to monitor the health condition of the patient every day, and to also make decisions, maybe, to give medication at the right point in time. So therefore, we develop systems. We focus specifically on Parkinson's disease, but this is just a model for other illnesses, because the same thing that we develop here works for Huntington's disease, and multiple sclerosis and knee injuries and many other movement disorders that we have already collected data for. But for the purpose of this talk, I'm just going to focus on Parkinson's. So what we need is good medical data, medical information that is connected to this disease progression. And therefore, we are currently in Erlangen setting up a system where different sectors of care, so the movement disorder unit, the individual physician, the expert physician, they all work together, they all deliver data about the status of the patient. And we are also, of course, connecting in a telemedical setting the patient himself or herself. So she can deliver data about her status back to that system. And we also connect other stakeholders that are important in this game. So in Germany, there's Parkinson's disease nurses that sometimes drive to the patient's home to give him or her a new dose of medication. And they could, of course, also contribute to this database and to this knowledge. And they actually do, so we connected them. So this is medical technology in real healthcare practice. And we are currently building the IT platform, the communication, the individualized patient history, everything that's important for this framework in the framework of a healthcare technology startup. And that's one of the startups that we founded out of our lab to actually do the technology transfer. So what do we connect to this platform? Video-based diagnostics, activity monitors, ECG, EMG. So a lot of the things that I showed you in this grand picture earlier, so every source of information you can think of. And all of them ask for you guys, or my expertise. So engineers that are interested in biomedical information that tease out the information from all these signals. So I could give you a half-hour talk about each of these signals, but I'm going to just focus in on the last one, on instrumented gait analysis, what we can derive from gait analysis and why this is so interesting in the next 5 minutes, and then we're done, okay? Just follow along for a few more minutes. Yeah, this is all connected to the patient needs through medical validated technology. So we will, in the second quarter of this year, we will release our first medical product that's gait analysis, that's doing gait analysis in this scenario. So this is hopefully contributing, so just as a reminder, to this future world of patient-centered healthcare technology, where we build a medtech device that's actually directly helping this person in the middle, the individual patient. So just if you have never seen a Parkinson patient before, let's look at their gait for a second. This is a real patient from our hospital ward. And then when you discuss this as an engineer, that's another type of test that every neurological hospital in this world does with the patient. So the first thing that the clinical expert that's 8 years ago asked you is, what did you notice? What did you notice?
He's bent towards his left side.
Yeah, bending is a typical symptom.
He's slower as well on the left
Slow,
to do the climb.
right? The left arm didn't swing. Notice that. And interestingly for us, all these things that we just said, so the leaning, the walking, the asymmetry, the bending, that all is reflected in your individual movement pattern. And we did a lot of tests for that, and we came up that with the solution that the best position to monitor these kind of symptoms is the foot. Because here you have the largest amplitude in movement of your extremity. You get a lot of comparable data, because as long as everybody moves, you can create data for these persons. So think about the Amazon example. You need a lot of data to relate that to something. And a third and super important argument about the feet is, and to me, the most important. Come on, guys, what's the most important thing I told you to remember that? Always think about your user. So the guys that have a disease that's targeting every day, so they don't want to put on an additional system. They don't want to even carry around a belt that's only made for this specific purpose. They just want to put on their shoes. And that's what we do. We include the sensing mechanism that we need to target this disease in a regular everyday shoe. So we get data from a system that's usable for the patient. And that's the system. So it's just simple. This is the old research system, by the way. So we attach the sensor to the outside of the shoe. So now with the company, we are putting the sensor inside the shoe. So we have specifically manufactured shoes for us by the industry with the sensors included. So these are going to be part of the medical product. And these sensors, these are just inertial measurement units, the same sensors that you have in your smartphone that turn the image in the right direction when you turn the smartphone. Deliver us the data that we need to assess the symptoms of the movement of the patient. And we collected a lot of data from movement exercises from the clinical routine. Over 1,500 individual patients, to our knowledge, that's the largest database on Parkinson's disease in the world. And this makes us train our algorithms. So now we're building algorithms that tease out the information from this very specific signal. What's the status of the patient? I won a lot of awards for that. So this is the Bavarian health minister, that's the Bavarian economical minister. So these are the two people that are most important in our funding. So that's something I learned. Always acknowledge your funding institution. There might be a picture from me right now, and if I don't acknowledge the funding, I wouldn't get it anymore. So this is very important in research. So this is how a typical movement recording looks like. So what are we working on here? We are building algorithms to detect the individual strides. We building machine learning algorithms that take the stride data apart. So we calculate all kinds of features, step length and stuff like that. And we're relating that to biomechanically important information. Why that? Because, again, the clinical expert wants to use that system. And we're working with that guy every day. So he tells us, if you don't tell me something that I can relate to, and I don't understand what a gradient of the swing phase of the foot in the air is, I don't understand it, but I understand 1.9 meters, 1.09 meters step length. That I understand, because that I work with every day. So if you can tease out these kind of parameters as well, you make the clinical expert happy. He will use your system, and then you can make a change in the healthcare ecosystem. So let's look at that for a second. How do we calculate stride parameters? Here we have the IMU data as an input. So just look at this complicated flow diagram. And at the end of the day, there's stride parameters that come out of that, stride length. This was the work of a PhD student, worked on that for 1.5 years. Why am I showing you that? And this is currently, as far as I know, the still best publication. We have the data set out there, so you can benchmark against that. So if you come up with a better solution, better recognition algorithm, please publish it and let me know. But one publication was better than that, and that's the following one. We did the same thing with a way different procedure. So we threw this all into the trash. We used a deep learning system, because you have to do that if you do work in AI, especially if you're a little bit crazy. So we did end-to-end learning, forgetting about all the complicated steps that we had in this procedure, just feeding the IMU data into a TensorFlow model and outputting things like step length and others. And we actually beat our own algorithm. So this is the old algorithm, 1.4 centimeters of error. And by the way, in a real biological system, the clinical experts always say, doesn't matter. I don't see 1.4 centimeters anyway. I just want to follow the progress. But nevertheless, as an engineer, you want to be better, right? You want to have something measurable. So 1.4 centimeters error, and the deep learning approach, 0.6 centimeters. That's less than half the error, and better variability as well. That's cool, right? What do you think, which of these sides is going to be implemented in the medical product? This one with the big red cross through it, or this one? This one. What do you think? Deep learning is the solution to everything, right? Who tends to disagree? I do. Who disagrees with me?
I kind of disagree. It's not so explainable as the other.
Right, that's the thing. So if you wanna certify a medical product, you have to tell the certifying agency what exactly your algorithm is doing. And deep learning is not the solution to everything, especially in medical, because in that approach, I can tell you exactly what every box is doing. But in the deep learning approach, if you feed the system a symphony of Mozart, I have no idea what happens. Actually, I do, because we did that. And it outputs step length, like completely stupid one, but it still outputs steps. But you get the point, it doesn't make sense. So I couldn't tell you what exactly happens. By the way, if you feed the same symphony of Mozart into this guy, it correctly doesn't recognize any steps. So that's a good thing. So that's still challenges that we work with. However, with the current system, we came up with something that actually helps the clinical experts and just some data so that the real engineers and academics here are happy. So we have stride length, for example, which relates very nicely with the progression of the disease. So this is progression. This is controls in the 1, 2, 3 stages. So getting worse of the disease. And you see that these measurable parameters are well connected to the disease progression. So this is again a problem because this is derived from many patients, 193 patients, but it's still a problem. Why? Because this is mean data. It's not telling something about my uncle. So we did the same study for my uncle. We looked at individual patients that are returning to the hospital. So these are follow-up visits. We have patients that get worse, that are stable, and that get better. And again, this is individual patients, and the disease course is nicely reflected in those measurable parameters. So that's what Jochen originally said. Oh, there's no star to that. So at a keynote in Boston, he said, "This is fantastic." So I'm just citing my clinical expert. So where are we going? In future, it will be important to use these data to give individual patients some information about their health data. That's the image that I showed you earlier. It's my health data. That's going to be important. And that's a project that we're currently conducting. We luckily got a huge funding from the European Union to make this vision come true. And that's this disease progression that I showed you earlier, connected to an individual's patient's route. So here we're seeing a Google Maps navigation system for patients. I have this change in my disease status. How is this relating to the other guy? Remember the Amazon example? That has the same kind of symptoms, the same kind of